It is already heard today that more than 50% of public water supply belongs to groundwater, overall data. But for Europe, 60%, for Serbia, 70%. From that number, more than half belongs to alluvial groundwater. So alluvial groundwaters are very important. One, and I would repeat again, that the very important habit is self-purification ability of alluvial groundwaters, which lead at the end to the baseline quality of the groundwater, and very important today when we are talking about protection and micropollution and everything. And in that way, it is very important the state of oxicity of aquifers, because it influences to a lot of very important processes and status of groundwater. The level of oxicity in an alluvial aquifer depends on the oxygen saturation of the river water, the oxidation and reduction processes of organic and inorganic matter, and the degree of oxygen restoration in the aquifer. This definition here is added a little bit more brave, inorganic consumption of oxygen, and it is important because mineral consumption is one of the things which is not very well explored, investigated up to now, and it is in front of us to do that better. Here we can see one longitudinal section of the aquifer from the source to the sea, and we see that at the upstream part of aquifer we have the coarse gravel and sand, and the middle less coarse, more fine, and the lower river course we have very fine sediments. Therefore, we have minerals which use oxygen too much in the lower part. So, in the upper part of aquifer, quite often we have oxygen state in the aquifer, oxic state in the aquifer, and the down part, lower part of the river course, we have anoxic situation. For instance, in Danube, therefore, we have very good wells. For instance, in Germany, in Regensburg, Professor Brauch knows for the well, which is in Regensburg about 300 liters per second, without clogging, very good for maintaining. Also, in Bratislava, we have even better wells, but when we go down in Novi Sad, for instance, we have several rainy wells with about 70 liters per second, no more than that. In Belgrade, where is the confluence River Sava to Danube, the average for one radial well is about 40 liters per second. The reason is the tiny particles which bring with them two valent iron and the problems with oxygen content in the water. Here we have schematic representation of our alluvial groundwater sources. One is bank filtration, the other is groundwater recharge. There are several very important points. First, the river, how to spare good quality of the rivers. Second, should be filtration through the to the bottom sediments, and also filtration through the aquifer. The third is well abstraction of water by well. It is important because there appears where clogging, especially due to aerobicity of an aquifer. At the end, water treatment and delivery of water. Similar, but not the same, is with artificial recharge. I will not talk about that now. And the third situation is small alluvial source at some distance from the river. Here we have the main is to have protection zone, and after that to have enough self-purification room to reach baseline quality of the water. If necessary, treatment; if not necessary, just disinfection. Conditions and processes substantially affected by the degree of toxicity, baseline quality of the water, very, very important. We do know that baseline quality for the groundwater vary very much. We have some waters with a lot of organic matter, some of waters very fine, possible to drink directly. The second, groundwater self-purification processes, I mentioned it, and the third, well aging processes. We will hear something about the three all points. Baseline quality, we see that surface water, we have just several parameters which are very characteristic. There are a lot of parameters we can talk about, but surface water differ from groundwater quite much, and we can see it on the table. Oxic groundwater can differ of anoxic groundwater very much, and we will just mention difference in iron content. Oxic very small or nothing, or almost nothing, and anoxic groundwater quite often it appears even in large concentrations. Oxygen, everybody knows that saturation is about 8 to 9, something like that, and that in oxic groundwater almost never it is exceeded, but could be several milligrams per liter, and the limit between oxic and anoxic could be something like 0.2 and 0.5. First, we have to define what is anoxic groundwater, and we can talk about anoxic bacteria which use the oxygen from the salts. Nitrates in oxic groundwater can be huge, or also due to pollution. In anoxic groundwater, no nitrates, and hydrogen sulfide also different for these two cases. Here we have phases of water filtration from the river to the well. River is the source for the water, very important to be protected and everything. Now Danube is better than in last 30 years was. Quite a number of big rivers are better, but has to be improved more. And now we faced with problem of micropollutants and emerging substances and so on. We have the phase 1 of filtration, underground filtration, that's through to the bottom sediments, very important, intensive sorption potential and the high biochemical activity. Phase 2, filtration occurring in predominantly oxic condition and using oxygen, and coming into the phase 3, anoxic or low oxic condition. Filtration occurring under diminished oxygen concentrations or under anoxic conditions. And phase 4, filtration within the zone of influence of the well screen. In anoxic conditions, in slightly anoxic conditions especially, we have the clogging of the well especially, and very often by trivalent iron, which comes from two-valent iron by biochemical reactions. Natural processes which lead to baseline quality, we have three the main points: transport via liquid phase, connective transport and dispersion, diffusion, transport from liquid to solid phase, transfer to solid to solution, and vice versa from solution to solid. Loss of substance from the aquifer, degradation process, evaporation, and some other. Here we can see Belgrade water source, more than 100 radial wells, and one diagram which shows the upper line is last 20 years consumption of potassium permanganate in river water, and the down line is a consumption of potassium permanganate in raw groundwater. You can see the difference, and that means that organic carbon from river water is diminished several times to become the groundwater and to be treated in the water treatment plant of Belgrade Waterworks. Here we can see the same thing with phenols. It was even when we have to protect one water source from the phenols from the river, it was bank filtration source, and we tried to investigate it in the field. We find out that in oxygen aquifer, the phenol is degradable, and in several days it comes from, let me say, 20 to almost 1 or null micrograms per liter. We can see here that we noticed in that time phenol was shifted in pyrocatechol, and it was registered. It was 1985. Here is German example. Professor Schmidt and Professor Brauch did it, and we can see in river Rhine bank filtrate reducing of different organohalogen compounds, and it's very interesting and huge work was to be done to achieve this graphic. Also, Germans, Schmidt and Professor Brauch, the similar like for Belgrade Waterworks, here we have bank filtration for the Rhine river, and the conclusion similar like for Belgrade. Oxic anoxic conditions, we have sequence of oxidants depending on the degree of oxicity. The strongest is oxygen, and it make oxidation of the other metals in oxic conditions, and after that nitrous, mangan, iron, sulfates, at the end manganogenesis. And different ways how it reached. This table is by Jürgens et al. 2010. Status in which certain significant substances are found in the groundwater: oxic NO3 to anoxic ammonia, oxic 3-valent iron to anoxic 2-valent, manganese 4 times valence, and anoxic 2, sulfates to sulfides, and carbon oxygen to methane. Well aging caused by iron. Now we can see well filter, and in the third phase of filtration, we have two valent iron soluble in the water coming to the filter of the well. It is supposed to be different redox in the well, maybe a little bit more than in groundwater, and we have shifting two valent iron to 3 biochemical processes. And it is very important process which leads to a lot of economy losses to the number of water sources. For instance, for the Belgrade water source, each year we have the loss about 200 liters per second of water because of the clogging. So it happens mostly in slightly anoxic conditions, for instance, between 50 and 200 millivolts of redox. In the past, it was established that criteria-based entrance criteria for entrance velocity of water to the well filter was given by Zichard. It was very old, 1928 year. Abramov, Pietraru, Kovac, Gavrilko, Alexeyev, and our authors Vukovic, Soro, Pušić. But it didn't take care about biochemical reactions. After that, a lot of authors examined what is happening with biochemical reactions. First, chemical, Langelier and Reisner, and after that, Dubinina, Kulimor, Mansey, and especially Hauben, who examined this thing. But they examined mostly chemical processes, but not the relation between hydraulic resistivity in the well and chemical indicators and processes. So therefore, we introduced here some, let me say, new parameter, local hydraulic resistance. We get it by dividing hydraulic resistance with well entrance velocity, and kinetic of local hydraulic resistivity, which means changing local hydraulic resistivity by the time. These factors are the function of redox conditions, of content of iron, of biological agent, and also of geometry of aquifer and some other parameters, but these 2-3 are most important. We examined it on maybe 150 wells, more than 5 years, and we find that there is a significant rising up the local hydraulic resistivity, and you can see a very characteristic diagram for the 5 wells, and that means that after some time you must make regeneration of the well or you must drill new well. So therefore it's very important to know what is the permitted velocity for the filter entrance, and that's really some job to find out this. We found that diagrams that kinetic local hydraulic resistivity depends of redox and also depends of the ferro content, and out of this is possible to obtain this. The horizontal lines are criteria which was given by Abramov, Sichard, Kovac, and the other all the masters, and this line which is under it is the criteria by biochemical reactions and indicators. Very important, because you can see that it is even 10 times difference between the old designing criteria and actual criteria which should be. It is very important economic issue now, and one must think about that very, very much when he has to design water source. Otherwise, he would pay much more. And at the end, conclusions. Alluvial groundwater is extremely important. Oxic conditions occur more often in the upper part of the river basin than in the middle, or especially in the lower part. Besides the degree of organic load, the mineralogic consumption of oxygen is also important. In oxic conditions, oxidation takes place through the oxygen dissolved in water. In anoxic conditions, biochemical oxidation is based mainly on nitrates, compounds of ferric iron, and tetravalent manganese, as well as sulfates. Fifth, various substances are often found in groundwater in different states of oxicity and element valencies depending on the degree of oxicity. The baseline chemical profile of groundwater quality depends on oxicity. 6, well aging due to screen clogging with iron deposits is a process of great economic significance. It predominantly occurs through a change of soluble iron into poorly soluble 3-valent iron. In the paper, the correlation between the kinetics of local hydraulic resistance variation in the well and clogging indicators is shown in that formula. We mentioned it. Area in which biochemical processes become dominant in relation to the aging of the well is basically the area of anoxic groundwater, redox less than 150, 200, something like that, not always quite proper, but about to be proper. Where there is a high oxicity, standard criteria, filtration, stability, and laminar flow to the well are the most significant criteria for the design of the well screen and its option. That means that in a very high oxic state, there is no microbiological processes or clogging. In the design of groundwater sources, protection zones, drainage facilities, and the like, it is important to properly address the oxic state of the groundwater. This can have a substantial technical and economic impact. And therefore, we have a team number 2, impact of oxicity to groundwaters. Thank you.